I am R.P. Tripathi. The lecture of the topic of this the lecture is linear differential equation of nth order with constant coefficient, complementary functions. First we define linear differential equation of nth order with constant coefficient. The equation is of the form a0 dn y dx raised power n plus a1 dn minus 1 y dx n minus 1 plus a2 dn minus 2 y dx raised power n minus 2 plus so on a n y is equal to q, where a0, a1, a2 and so on a n are constant and q is the function of x only. The equation of 1 is said to be non-homogeneous equation of nth order when q is not equal to 0. When q is equal to 0, the equation 1 is said to be homogeneous linear differential equation, that is a0 dn y by dx n plus a1 dn minus 1 y dn x minus 1 plus a1 a2 dn minus 2 y dx raised power n minus 2 and so on a n y is equal to 0. Means if right hand side is equal to 0 of 1, it is said to be homogeneous linear differential equation. Equation 2 can also be rewritten as a0 d capital D raised power n plus a1 d n minus 1 plus a2 d n minus 2 and so on a n y is equal to 0, that is f d y is equal to 0, where d stand for d by dx, means it is differential operator, where f d is a0 dn d raised power n plus a1 dn minus 1 plus a2 dn minus 2 and so on a n, means it is f d is the differential operator of the given differential equation. Solution of homogeneous linear ordinary differential equation. How we find the solution of the linear differential equation? The homogeneous equation 4 can also be solved by replacing d by m in f d, means we have to convert operator equation in the form of algebraic equation. And solving the auxiliary equation f m is equal to 0, means operator f d can be changed to f of m is equal to 0. The general solution of 4 depends upon the nature of the roots of the auxiliary equation 5. If m, m1, m2, m3 and so on mn are n roots of the auxiliary equation, the following case arise. First case, real and distinct roots. If the roots are real means m1, m2, m3 and so on mn are real and distinct, then solution is C1 e raised power m1x plus C2 e raised power m2x plus C3 e raised power m3x and so on Cn e raised power mnx. If it is nth order, means the solution containing n arbitrary constants, where C1, C2 and so on Cn being arbitrary constant. The main aim, the question arises that how we find the solution of in this form of exponential, means suppose we have dy by dx is equal to y. It is the differential equation, and how we find the solution of this differential equation, means we have to write down dy minus y is equal to 0, means sorry, dy by dx, this means d minus 1 y is equal to 0 means f d y is equal to 0 means where f d is equal to, where f d is equal to 0, f d is equal to d minus 1 means d, we have to replace d by m, and we get auxiliary equation is obtained by f, auxiliary equation is obtained by f m is equal to 0 means m minus 1 is equal to 0 means m is equal to 1. The solution is obtained by, the solution is y is equal to c 1 or c e raised power 1 x means c raised power x. It is the solution, and our solution in the form of exponential form. The second method, it is the direct form. Suppose we have dy by dx is equal to my. We want to find the complementary function or solution of this ordinary differential equation of this type, of exponential type, means we have y is equal to, sorry, it is m1 y, it is m1 dy by y, and it is dx, dy by dx, y separation, separable or variables means dy by y is equal to m1 dx means integrating dy by y is equal to m1 dx, integrating we get log y is equal to m1 x plus log c1, or y is equal to c1 e raised power m1 x. It is the solution. This is why we can find the solution of a differential equation in the form of exponential y is equal to c1 e raised power m1 x. Let it is second order differential equation, means we have two arbitrary constant d2y by dx square plus 3 dy by dx plus 2y is equal to 0. It is second order differential equation, means we have to convert this into the differential equation into operator form, means d square plus 3d plus 2 y is equal to 0, where d stand for d by dx. Complementary function auxiliary equation is obtained by replacing d by m, means m square plus twice m, thrice m plus 2 is equal to 0 means m plus 1 into m plus 2 is equal to 0 means m is equal to minus 1 and minus 2, means m1 is minus 1, m2 is minus 2, means the solution is y is equal to c1 e raised power m1 is nothing but it is 1 x, m1 is solution is y is equal to c1 e raised power minus x plus c2 e raised power minus 2x. It is the solution. It is the third order differential equation, d3 y by dx cube minus 7 dy by dx minus 6 y is equal to 0. The given equation can be rewritten in the form of, in the operator form, d cube minus 7d minus 6 y is equal to 0, where d stand for d by dx. The auxiliary equation is obtained by putting d for m, replacing d for m, means we get m cube minus 7 m minus 6 is equal to 0, or the factor of the factor of m cube minus 7m minus 6 is equal to 0, or m plus 1 into m plus 2 into m minus 3 is equal to 0, means m is equal to minus 1, minus 2 and 3, means m1 is equal to minus m1 is equal to minus 1, m2 is equal to minus 2, m3 is equal to 3. The general solution is y is equal to C1 e raised power minus x plus C2 e raised power minus 2x plus C3 e raised power 3x. The next example is solve d raised power 4 minus 81 y is equal to 0, where d stand for d by dx. The auxiliary equation is m raised power 4 minus 81 is equal to 0, means we have m square minus 9 into m square plus 9 is equal to 0, means m is equal to 3 minus 3 and 3i and minus 3i, means 2 roots are real and 2 roots are imaginary. The part of CF corresponding to real m, means m is equal to 3 and minus 3 is C1 e raised power 3m plus C2 e raised power minus 3x. Also the part of CF corresponding to 3i and minus 3i is C3 cos 3x plus C4 sin 3x. Hence, the general solution is the combination of both, means C1 e raised power 3x plus C2 e raised power minus 3x plus C3 cos 3x plus C4 sin 3x, means it is fourth order differential equation, means it must contains four arbitrary constants. Solve d raised power 4 minus 6 d cube plus 12 d square minus 8 d y is equal to 0, d where d stand for d by dx. How we find the solution? It is directly in the form of operator form, means we replace d by m, means m raised power 4 plus 6 m cube plus 12 m square minus 8 m is equal to 0. Take m common, m cube minus 6 m square plus 12 m minus 8 is equal to 0, means it is m into m minus 1 m minus 2 whole cube is equal to 0, means the value of m is 0, 2, 2, 2, because it is coincident, the coincident roots. M is equal to 0, means m1 is equal to 0, m2, m3, m4 is equal to m is equal to 2. Hence, the root here m is repeated thrice. Hence, the general solution is C0 e raised power C1 e raised power minus e raised power 0x, because m1 is 0, C2 plus C3x plus C3x square into e raised power twice x, or C1 plus C2 plus C3x plus it is C2, it is not C3, it is C2, C3 and it is C4, it is C4 x square, C1, C2, C3, C4 x square, C1, C2, C3, C4 x square. It is not C3, but it is C4, because it is of the fourth order, means we have 4 constant arbitrary constants. Solve d cube plus 1 y is equal to 0, d stand for d by dx. Auxiliary equation is m cube plus 1 is equal to 0. We factorize into the linear factors m plus 1 under bracket m square minus m plus 1 is equal to 0 means m plus 1 is equal to 0 and m square minus m plus 1 is equal to 0 means m is minus 1 and it is second m is 1 by 2 plus minus under root 3 by 2, it is I, it is imaginary I, it is complex form, it is I. Hence, the general solution is m1 is minus 1, m2, m3 is 1 by 2 plus minus root 3 by 2 I. Hence, the general solution is C1 e raised power minus x plus C2 e raised power half because it is real e raised power half x C2 cos root 3 by 2 x plus C3 sin root 3 by 2 x means it is the differential equation contains real roots as well as complex root, one real and two complex roots. The solution is this, the solution is this. Solve T4 minus 4 d cube plus 8 d square minus 8 d plus 4 y is equal to 0, where d stand for d by dx. How we find the solution? We first find auxiliary equation, and auxiliary equation is obtained by putting d for m or m for d, means we replace d by m, means we get m raised power 4 minus 4 m cube plus 8 m square minus 8 m plus 4 is equal to 0. We factorize it, we get m square minus twice m plus 2 whole square is equal to 0, means m square minus twice m plus 2 is equal to 0 twice. We break into the linear factors, we get m is equal to 2 plus minus root minus 4 by 2 means 1 plus minus I twice, because it contains fourth order differential equation. Hence, the general solution is y is equal to, since 1 is real, e raised power x C1 plus C2 x cos x plus C3 plus C4 x sin x. It is the solution. Here we have, suppose we have dy by dx plus thrice y is equal to 0, means dy by dx is equal to minus 3y, means variables are separable, means dy by y is equal to minus 3x 3 dx. Integrating, we get dy by y is equal to minus 3 dx plus constant of integration, where c is the constant of integration, means integrating we get log y is equal to minus 3x plus c, minus 3 where c is the constant of integration. For taking the solution, we have log y is equal to minus 3x plus log c1 where c is taken log c1, means y is equal to c1 e raised power minus 3x. Here if we want to find the solution of d2y by dx square minus 5 dy by dx plus 6 y is equal to 0. It is the second order partial differential equation, second order ordinary differential equation. We find the solution means first we have to convert the given differential equation into operator form, means d square minus 5d plus 6 y is equal to 0, where d stand for d by dx, means auxiliary equation is obtained by replacing d for m, d by m square minus 5 m plus 6 is equal to 0, means m square. Here we factorize and factorize into linear factors, means 6 means minus 3 m minus 2 m plus 6 is equal to 0, means m minus 3 and minus 2 m minus 3 is equal to 0, means m is equal to m minus 2 m minus 2 and m minus 3 is equal to 0, means m is equal to 2 and 3. The solution is y is equal to C1 e raised power 2x plus C2 e raised power plus 3x e raised power 3 plus 3x, not minus, it is plus 3x, means it is the solution of the given ordinary differential equation of the second order. Suppose we want to find the solution of d2y by dx is square plus a is square y is equal to 0. It is second order differential equation. First we have to convert the given equation into operator form, d square plus a square y is equal to 0, where d stand for d by dx, means auxiliary equation is obtained by putting m for d, means this is equal to 0, means m square is equal to minus of a square, m square is minus of a square, means m is equal to minus of a square, means a root minus 1, means m is equal to plus minus a I, means the solution is y is equal to C1 e raised power a I x plus C2 e raised power minus a I x. Expanding by Euler formula of this exponential, and we combine C1 and C2, we get a cos ax plus b sin ax. Expanding it means cos ax plus I sin ax, it is cos ax minus I sin ax, combine sin and cosine terms, we get another constants a and b, and we will get cos ax plus sin ax. Here I like C1 e raised power a I x plus C2 e raised power minus a I x. Combine it, and the solution is y is equal to a cos ax plus b sin ax, means C1 cos ax plus I sin Ax plus C2 means this C2 cos Ax minus I sin Ax, because power is negative. Combined cos and cos means we have C1 plus C2 cos Ax plus I C1 minus C2 sin Ax. It is another constant, it is A cos Ax plus it is B sin Ax, means solution is obtained as usual manner, means we have to convert C1 e raised power aix plus C2 e raised power minus aix. Solution is this, and how we can find this solution? We have to expand exponential e raised power aix or iax, means cos ax plus I sin ax plus C2 cos ax minus, because power is negative, I sin ax plus C1 plus C2 combines cos and cos, we have C1 plus C2 cos ax. Here I C1 means I take outside common, we have C1 plus minus C2 sin ax. It is C1 plus C2 is another constant, means we have A cos ax plus B sin ax, means it is the solution of the differential equation d2y by dx square plus a square y is equal to 0, a square y is equal to 0. We have already explained it. It is the solution of d2y by dx square minus 5 dy by dx plus 6 y is equal to 0. We have to convert the given differential equation into operator form, then we find our auxiliary equation and we get the linear factors m is equal to 2, means m1 is equal to 2, m2 is equal to 3, and the solution is C1 e raised power twice x plus C2 e raised power thrice x. We have already explained it, dy by dx plus 3y is equal to 0, how we find the solution into exponential form and cosine sine form. It is fourth order, we have already discussed. Thanks.